Hello there guys, so for today's video, we will be talking about the summary of chapter 6, which is entitled Network Layer. So for today's video, again, my name is Margins Frago, and I am from BSIT 2107. And so, to start the introduction, uh, describe the purpose of the network layer in data communication, explained why the IPv4 protocol requires other layers to provide reliability, include media independent, reliable, and connectionless. So what is the network layer? End-to-end transport process. So it is addressing end devices, encapsulation, routing, and the encapsulation. So this one, guys, is the topology, or rather it is the representation of the exchange data of the network layer. It is the end-to-end transport processes. So network layer protocols, so we have Internet Protocol version 4, IPv4, and Internet Protocol version 6, IPv6. So the IP stands for Internet Protocol, V is for version, and 4 and 6. So what the characteristics of the IP protocol? Encapsulating IP. Transport layer PDU is equal to segment. So it says that the transport layer adds a header so segments can be reassembled at the destination. So next one is the continuation of encapsulating IP. It is the network layer PDU is equal to IP packet, transport layer encapsulation, and the network layer encapsulation. As you can see, guys, this is the topology, or this is the representation of network layer PDU is equal to packet, IP packet rather. So characteristics of IP: the connectionless, best effort, and media independent. So IP connectionless, and it says that if the sender doesn't know if if this receiver is present, if the letter arrived, if the receiver can read read the letter. So next one, the receiver doesn't know when it is coming. IP connectionless. So a packet sent if the sender doesn't know if the receiver is present, if the packet is arrived, if the receiver can read the packet, and also the receiver doesn't know when it is coming. IP best effort delivery. So IP packets are routed through the network quickly, and some packets may be lost en route. IP media independent. IPv4 packet header, and version is equal to 0100. DS is equal to packet priority. TTL is equal to limits life of packet. Protocol, upper layer protocol such as TCP. And next one is source IP address is equal to source of packet. And destination IP address, destination of packet. Limitations of IPv4. So IP address depletion, internet routing table expansion, and lack of end-to-end connectivity. So introducing IPv6, increase address space, improved packet handling, eliminates the need for NAT. So, 4 billion IPv4 for version 4. IPv4 addresses 4 billion, if I'm not mistaken, 100,000 mil. 4 million, I'm sorry, 4 billion rather, versus 340 undecillion IPv6 addresses. Encapsulating IPv6. So this is the representation. IPv6 has a simplified header. So for yellow one is for fields name kept from IPv4 to IPv6. The blue one is name and position change in IPv6, and the violet one is fields not kept in IPv6. Encapsulating IPv6. So what is the advantage in IPv6? So better routing efficiency for performance and forwarding rate scalability. No requirement for processing checksums. Simplified and more efficient extensions header mechanisms as opposed to the IPv4 options field. So next one is a flow label field for per flow processing with no need to open the transport inner packet to identify the various traffic flows. So the default gateway routes traffic to the other networks, has a local IP address in the same address range as other hosts in the network, and can take data in, forward data out. Using the default gateway, this is the default gateway. As you can see, this is the representation of host default gateway. The IP address of the R1 interface is the default gateway address for PC1 and PC2. And for router packet forwarding decisions, directly connected and remote network routes. So R1 has 3 directly connected networks: 192.168.10.0 over 24 and 192.168.11.0 over 24 and 209.165.200.224 over to 330 rather 30. R1 also has 2 remote networks that it can be learned about from R2 10.1.1.0 over 24 and 10.1.2.0 over 24. So this is the directly connected routing table entries under understanding local route entries, and the root source identifies how the network was learned by the router. Destination network identifies the pink one, the destination network and how it was learned. And the orange one, the peach one is outgoing interface, identifies the exit interface to use to forward the packet toward the final destination. So let's skip that. A router is a computer or router CPU and OS. Routers require central processing units or CPUs, operating system or OS, memory consisting of random access memory or RAM, and read-only memory or ROM, and non-volatile random access memory or NVRAM, and flash. The Cisco Inter-Network Operating System or IOS is the system software used for most Cisco devices regardless of the size and the type of the device. So the router memory, RAM uses the following applications and processes: iOS and running config, routing table, ARP cache, packet buffering. So RAM stores the following: boot up information that provides the startup instructions, power on self tests, post that tests all the hardware components, limits iOS to provide a backup version of the iOS. So as you can see guys, this is the inside of a router. So this is the synchronous dynamic RAM, or SDRAM, used for holding the running configuration and routing tables and for supporting packet buffering. So it is very important. So this is the parts of connecting to a router. So we have double wide, or EHWIC slots. We have two 4GB flash card slots, EHWIC0. Console USB Type B. Console RJ45. Aux port. LAN interfaces. USB ports. So this is the LAN and WAN interfaces. So we have serial interfaces. As you can see guys, this is the serial interfaces, and this one is the LAN interfaces. So let's skip that guys. So basic switch configuration steps. So the step 1 is the configure the device name or host name. Secure, next one is secure exec mode, line console 0, password, login. Third one is secure remote telnet or /SSH access. Secure privilege exec mode. Secure all passwords in the config file service password encryption. Provide legal notification or banner MOTD. Configure the management SVI and save the configuration. So this is the basic router configuration steps. Limiting device access. Configure the device name. Secure host exec mode. User exec mode rather. Secure remote telnet SSH access. Secure privilege exec mode. Secure all passwords in the config file. Provide legal information. Save the configuration. So configure router interfaces. So the steps of configure configure the interface type and number. Description to text. IP address, IPv4 address, subnet mask, no shutdown. And verify interface configuration. Show IP route, displays the content of the IPv4 routing table or stored in RAM. Show interfaces, displays statistics for all interfaces in the device. Show IPI interface, device displays the IPv4 statistics for all interfaces in a router. So the summary of this chapter 6 is the objectives. Explain how network layer protocols and service support communication across data networks. Explain how routers enable end-to-end connectivity in a small to medium-sized business network. Explain how devices route the traffic in a small to medium-sized business network. Configure a router with basic configuration. So that's all for chapter 6 guys. The summary of chapter 6. Thank you for watching and staying on this video. So I hope you gained a lot of learnings for this summary chapter 6 on CCNA 1. Again guys, Um, for my next video, just wait. I will do the summary of chapter 7. Thank you guys.